Hello, I am Ramdijit. I am today discuss Scott analysis. Firstly, we analyze mechanical analysis, levers, angles, and force. The mechanical analysis of the skirts, the deployment of the rotation force throughout the range of motion. This force, called movement force, is greater the further the barbell moves horizontally from one of the body joints. The distance is called a moment arms and relative length of the moment arm affecting each joint so the relative position overall force. The top of the skirt. At the top of the skirt, the lifter is standing in relatively straight vertical line with barbell on his back. You can see in this verbal, the force acting on the body originate with the force of gravity pull down on the barbell in straight vertical line. The The bar is held directly over the middle of the put so that the whole system is considered in balance. The condition of balance remains throughout the entire movement. Analyze are the back, the femur and the lower back. They hang around the hip and knee joints. Angles used to analyze and discuss the movement. These angles are in hip angle defined as the angle formed by the plane of the torso and femur, the knee angle formed by the femur and the shank, and the back angle formed by the plane of the torso and floor at the top of the skirt. These angles are completely upon placing the back thigh and sag segment 0 degree to vertical force of gravity acting on the barbell. The bottom of moment is defined by the hip angle dropping below the horizontal plane parallel to knee. The knee, hip and back angle have closed further. The hip have pushed back as the hip back angles have closed in to keep load balance over the middle of the foot. The closing angles created a horizontal displacement of joints rotation. The knee and ankle relative to the vertical gravity acting on the barbell. Gravity acting on the barbell is transmitting force along with body levers to these points of rotation. The amount of force being transmitted each of these points directly proportionate to the length of moment arms acting on each lever. Two levers and moment arms affect the hip joints. The back lever is distance from where is bar is geared to the hip measured along with to the plane of torso. The horizontal displacement of these 2 points create a moment that's the equal of the horizontal distance between them. The other lever affecting the lift along with proximal femur, the gravity across the femur, creating a lever segment between the point and hip the joints. In this video, this lever movement are equal to horizontal distance between the hip and gravity. The moment for along these levers are controlled by hip in the correctly performed score. So many things keep in mind. The barbell is directly over the middle of the foot. This is no moment force affecting this balance point with the ground and the lifter valve system is therefore in balance. Next point is our standing back up. The squat places the largest distribution of the load on the hip. The levers controlled by the hip are along the back and proximally fewer and they have the longest movement arms. Various of the many variants on the squat, each at the front squat or thigh bar squat change the relative length of movement or a movement in these versions of the squat. The effect of these differences are much shorter movement arms affecting the hip weight. The vertical back angle and the hip angle have brought the hip horizontally close to the barbell. And the larger movement arm affecting the knee as the closed knee angle has caused a more knees forward position, moving the knees horizontally further from the load. Next point is anatomical analysis, bones and muscles. Model based on levers, angles, and movement for it is necessary to next put the model in